So let's begin the exploratory data analysis and feature engineering. Now, for the capstone project, I wouldn't, however, be doing the coding for EDA and feature engineering. It would be expected that you would code on your own and complete the project. In this section, the objective of the session is to actually give you a basic approach, a couple of refreshers of what needs to be done, and what kind of what are the different approaches that you could take, what alternatives exist, and at a high level, you're kind of defining the approach that you would need to adopt to move on from EDA feature engineering to actual machine learning development. So let's get started. I'll just show you a brief overview. I'm importing the data. I would recommend you to actually start with the data that mentions as bank additional full CSV. From the same source, this has the exhaustive list of customers with all the attributes required. Now, as we already know, we start with the simple step. We say df.shape. And we see around 40,000 rows and 21 columns. So let's say df.columns. And you understand we have data at a customer level. So we have the customer's age, the kind of job, his marital status, education, default, whether he has defaulted in a loan previously. Housing and loan would actually indicate whether he has a housing loan, whether he has a personal loan. Probably contact defines the number of times he's been contacted, month, day of week, would actually be the descriptive attributes like what month and what day of week has he been contacted, and a couple of other numeric variables like number of employees at that point of contact, and probably a couple of terms which is kind of not clear here. So this is just a basic overview by looking at the column names, and I presume this would be the y variable, which is the outcome, whether he has converted or not. Now, to understand better these columns, what we would do is we'll say first df.dtypes. That will give us the data types, and you can see a couple of them are object, which means categorical, and remaining a couple of them are actually numeric. This gives us kind of a better idea of what the columns look like. Let's just say df.head, and we look at the first 3 rows in the data set. So how does it look? Age is a gendered number, job is the kind of job he has, housemaid, services, etc. Marital status will have values like married and so on. Education would be high school, basic, etc. Default is yes, no, and probably even unknown. Housing is yes or no, it's a flag. Loan again would be yes or no. Contact is the means used to actually contact a person, and so on. And this is the end outcome variable that will be required to model. Now, for additional information on all of these other columns, you could actually leverage the data description available in the same link which I have provided. So if you open up the same link, over here, you will have attribute information. So you can see, okay, 21th column Y has the outcome that the client has subscribed a term deposit. It's a binary value which has values like yes and no. The number of employees at that point of time, Euribor 3-month rate. I'm not really sure what this means. We would need additional research over here. Consumer confidence index, consumer price index, employment variation rate. Now, these are terms associated more with the banking domain. If you are new to the banking domain, it's highly advisable to actually understand the impact of these 3 different variables on the kind of outcome you're looking at. When we're looking at P outcome, the outcomes of previous marketing campaign, which is a failure, non-existent, or success. So if the customer is previously contacted, what is the outcome? Was it a successful outcome, failure, or he was never contacted previously? Then the number of days. So if you look at a high level, we have attributes of the customer, of his relationship with the bank, like whether he has a housing loan, personal loan, whether he has defaulted. We have information about the previous campaigns, like how many times he's been contacted previously. We have a couple of microeconomic factors which are related to the banking industry, and we have his end outcome. So overall, we have a rich set of attributes that help us define the problem. So let's get back to the next step. So if you study these attributes clearly, you will actually get a more high-level understanding of what is your data telling. Now, after this, which is what is the right next step? So if you remember from module 3, the first step which we need to take after ingesting data or after understanding the data's length and breadth is univariate analysis. So I'm not going to code and actually showcase each of the analysis outcomes for univariate, but then essentially what you would do is you would consider two separate categories, numerical columns and categorical columns, and look at what does each of these attribute talk. Once you finish univariate analysis for numeric as well as continuous attributes, the next step is ideally to move on to bivariate analysis. So when you're talking about bivariate analysis, you have a simple outcome, which is yes or no, and you would actually understand the impact of any one of these variables on the outcome. So for example, let's say you would understand what is the conversion rate of people of different education. So the hypothesis would be, okay, people of high school will have more conversion rate, people of basic education will have lower conversion rate. Now, when you study the impact of different bivariate studies, like age across the outcome, campaign across the outcome, and so on, this will help you to understand kind of at a high level what is the impact of each of these individual columns on the actual outcome. Again, one point over here, when you're doing bivariate analysis, again you have two different scenarios. You would have a categorical variable and a numeric variable. So over here, in this scenario, the binary variable which you have over here is actually an object. So it is a simple yes or no. So if you're doing simple binary outcomes, it might not really be straightforward for you. You will need to convert this to a flag or a numeric outcome. So you can use a simple if else condition and convert this, or you can use the binary, you can use a label encoder, a package available under sklearn. I'll just show that illustration and I'll show you one example how we can go forward. So let's say from sklearn dot preprocessing, we import label encoder. Now let's say we say le is equal to label encoder. We instantiate an object and we will say df dot y new, which is the modified y, is given as le dot fit transform, and we pass the previous column, that is df y. And if you look at the output now, let's say I will say df, let's do a head command. Now if you look, we have yes and no associated as 0 and 1. So this is now a numeric outcome. Now if you want to do a simple bivariate analysis across two different objects, you can actually build, you can actually then study the relationship using the different plots like bar charts, stack column charts, which we learned while exploring module 3. Let's take, so coming back to the topic, we have different plots to understand the kind of impact of one independent variable on an outcome variable. So if you want to simply do a basic check on how does your bivariate analysis work now, you can say you can study the outcome of default, that whenever the person has defaulted, what is the actual impact on your outcome variable. So you'll see a variation. Okay, fine. Whenever the default was yes, there's a lower conversion rate. When the defaulting was no, there's a higher conversion rate. And when the default was unknown, there's a moderate conversion rate. So these are the different techniques you can use to actually perform bivariate analysis. So at a high level, you would use the same steps which we studied while exploring univariate analysis, bivariate analysis, and complete your basic understanding about the data. Now, the next step would ideally be to, once you have finished understanding univariate and bivariate analysis, the next step would actually be to go ahead and complete feature engineering. Now, feature engineering, it's best with domain knowledge. since you would actually be missing some banking context or BFSI domain context over here, the general approach to acquire basic information about the industry would be just try to understand how does the different variables mentioned over here, consumer pricing index, consumer confidence index, Euribor Express, all of these different variables, how are they associated with the banking industry and what kind of impact do they have? And you can just try Googling basics about the industry and you can understand what is the kind of impact of these variables on your end outcome variable. You would also need to do outlier treatment because I'm sure a couple of these numeric variables will definitely have outliers. And not just numeric variables, categorical variables will also need treatment. So as a part of feature engineering, there might be a need to actually reduce the number of levels in one of these categories. So over here, the structure looks straightforward, but then if you look at job, I'm kind of sure that the number of values that come on the job, let's have a look at it. So we'll say df, and we'll say job, let's say value counts. So if you look over here, we have a lot of different values over here, and most of them kind of come into admin, a huge chunk under blue collar, technician, and the number keeps tripping. So even though these number of distinct rows is not really very big, let's say the total number would be something around 15. But then if you kind of reduce that to a certain level. Now, the first thing would be you study them and you see whether there's an impact. What is the kind of impact across all of these attributes? Now, these top 5 would actually be the biggest chunk, and the remaining will have kind of smaller impact. Unless you see something really interesting over here. So something interesting would be, okay, unemployed, and when you have unemployed, you have around 1,000 people in that domain, and you see the conversion rate is 0. And the conversion rate across all of the levels is kind of at least 25 to 30%. But then something over here is extremely unusual. So that would mean, okay, fine, you can actually consider separately. You can't combine this with others. So what I'd say, as an act to reduce the number of levels, let's say the top 5 as they are, the next 4, 5 as just a single unit as others. You'll keep one of them as separate if in case it's interesting, something like that. And at the end, let's say you have 5 or 6 distinct values over here, you're kind of reducing the noise in that categorical column. But this again requires a bit of judgment, and that needs iterations. So feature engineering also comes in formats of transforming the numeric variables. So I see number of employees, and if I'm not wrong, number of employees. This would indicate the number of employees in the bank at that point of marketing campaign. So this would roughly convert to a number which is not having a lot of variations. So let's say the company is having around 5,000 employees, the numbers kind of increase between 100 more or 100 less. You won't see a lot of variation. So rather than keeping this as a number as it is, you could use the scaling standard scaler, and you could actually normalize or standardize these numbers. That will have a better impact. Same, if let's say there's an impact from let's say if some values don't have any variations, you could actually drop that column, or actually you could use a standard scaler or normalizing start process to actually go forward. So that's the basics about EDA and feature engineering. I've just discussed a basic kind of approaches that you could take forward to implement in this project. The actual outcomes from feature engineering is an endless list. You really don't have a structured way to understand what are the most appropriate ways to go ahead with feature engineering. Now, the more you research and understand, the better approach you will have to understand the data and develop features. So that's just the basic overview about this process. I would recommend that you get started with this process with a lot of diligence, explore the data. You might actually get frustrated in the process because it's an iterative process. But then please don't leave any corners any corners to in the process of understanding the data. It's an iterative process. It takes time. And honestly, feature engineering and EDA is the time where you spend majority of your bandwidth in any machine learning project. The next steps are less effortsome. You don't really spend a lot of time over there. Significant part of your time is actually spent in cleaning, processing, understanding, and augmenting the data sets. Now you will have to use all those visualization techniques in conjunction with univariate bivariate analysis so that you can actually do better feature engineering. Uh, the entire visualization process is incomplete in the EDA. It will only help you to understand the data in a much better way. So please don't miss out on creating plots, a variety of different plots. You can try combinations of bar charts, star bar charts, explore what are the different techniques available within Matplotlib, and then leverage all of them to reach to a conclusion for EDA and EDA and feature engineering. So that's about this. We move on to the next topic. So before you watch the next video, I presume that you would have already practiced a lot on EDA, and you would have tangible outcomes. Because in the next video, I'll be talking about what kind of challenges you would expect to face in the machine learning technique, machine learning development for this particular module. So before moving on to the next topic, I would highly recommend all of you to first finish the EDA and feature engineering process and only then move on to that topic. Else the topic will actually be not much value. So that's it. I'll meet you after EDA and feature engineering in your project.